air, earth, water. Always were, always will be, essential to our lives, worth protecting. In the 21st century, we meet that challenge in one of the great freshwater regions of the world.
Project Clean Lake is the Northeast Ohio Regional Sewer District's 25-year commitment to clean water in our region, specifically to address the combined sewer overflow issues that have been plaguing our region for decades. Our region has an older sewer system where the stormwater and sewage is contained in a single pipe. And that single pipe is fine when it's not raining, but when it rains, that single pipe is not big enough. And our current system overflows during rain events from that sewage pipe into the environment, into Lake Erie and the surrounding streams. When it rains, instead of overflowing into the stream and into Lake Erie, the water will drop down into a deep storage tunnel. It'll be held there until the rain subsides. And then at some point then, it'll be pumped out and discharged into our wastewater plant where it will be fully treated prior to being discharged into Lake Erie or any of the rivers.
Euclid Creek is one of 7 huge tunnels that will safely store water overflow until it can be treated. A tunnel. Sounds simple enough. In fact, it takes an expert to build a tunnel. This is where McNally International and Kiewit Corporation, 2 powerhouses in underground construction, excel. An established joint venture, uniting knowledge, experience, equipment, local presence, talented people, and the day-to-day partnering skill it takes to complete cost-effective, large-scale infrastructure projects on time. Building Euclid Creek Tunnel, McNally Kiewit brings Northeast Ohio 3.5 miles closer to realizing the vision of Project Clean Lake.
Combined, McNally and Kiewit have over 150 years of underground experience working on underground projects. That allows the company to use proven construction methods to ensure the highest quality project to our owners, our clients. It's not just the 2 organizations, it's bringing in other contractors with experience. To bring everybody together and to be able to manage people is a huge undertaking and one that requires a lot of experience to be able to do that. One of the things the owner likes to have and wants a good quality project. They want to hire a contractor that's responsible. And what we do going in is we like to have an open, transparent relationship with the owner. Partnering, team building, laying any issue that's out there down on the table so that we can discuss and work through those issues. At this point in the project, being a month ahead of schedule goes 100% towards the staff and having the right people in place along with the workforce to be able to execute 3-shift mining and to keep the maintenance done when it needs to be done.
I've been very, very pleased with the McNally-Kiewit joint venture. That was the low bidder on Euclid Creek Tunnel in terms of the quality of the people that they deployed to the project. Very often you can get a good contractor, but you don't get their A team, you get their B team. I think in this case of Euclid Creek Tunnel that we got lucky. We got a good contractor and we got their A team. I feel that the relationship's been very positive. I feel that whenever I've had an issue as a client, they've been open to listening to the issue. They've been amenable to taking action to try to resolve the issues. And it's been a very positive, relationship. And I'm happy with the end result.
200 feet underground, there's a mobile factory constantly at work. It's simply called a tunnel boring machine, or TBM. It's precisely 27 feet in diameter and about 350 feet long, moving ahead, mining and building, fabricating as it goes. One branch of the system that will assure clean water for 64 communities. The leading edge of the entire mobile factory is the 27-foot diameter cutter head. 52 cutters breaking up shale at a rate of 5 inches per minute. May not sound like much, but that's traveling 25 feet every hour through rock. More than 14,000 cubic feet excavated, or 1,200 tons of crushed shale carried away hourly by an 8 conveyor system.
A well-designed conveyor system is important to the tunnel operation because if the conveyor system can't keep up with the TBM, then it's just going to limit the rate that you can build tunnel and mine tunnel. It's important to size the conveyors appropriately to the advance rates that you want to be able to achieve. The ECD conveyor system is approximately 9 conveyors. There's a short, stout conveyor right behind the cutter head that collects the material right after it's excavated on the TBM. It carries it to a long backup belt conveyor, and that spans the roughly 300 feet length of the TBM. From there, it's transferred to the tunnel belt, which goes from the back of the TBM all the way through the tunnel from start until we haul through about 3.5 miles down.
All told, more than 36,000 feet of conveyor, perfectly maintained and constantly moving with the cutting cycle, through the tunnel and straight up 200 feet to the surface. The conveyor starts here, just behind the cutter head, in what's known as the main shield, where virtually all the factory support systems originate. Ventilation and dust control, hydraulics, pneumatics, electricity and electronics. All these factory systems grow and advance following the cutter's majestic progress.
With my guidance, I'm controlling my cylinders to keep on track, keep it centered with the laser. So I steer it down here with the pressures. It updates about, I say, every 15 to 30 seconds. So it's giving me a tendency which way I'm going, up, down, left, or right. Plus I'm watching my speed at the same time and watching my penetration of the rock. And then I have to keep the speed of the wheel up. That helps the penetration and the speed overall.
Every 15 to 20 minutes, it's time to build. During the mining cycle, custom-built rail cars guided by diesel locomotive move down the tunnel track to deliver to the unloading station locally fabricated, precast, reinforced concrete segments. 6 segments form one complete ring of the finished tunnel wall. Transferred to the feeder table by vacuum-powered crane, each segment is indexed for the erector.
Basically, the segments come from the top, they come down to us, and then we put the rings in place after they mine ahead. And then when we're done placing the rings, then they can continue to mine. And then we just keep the process going. The computer tells us where we're gonna place the first stone. We grab the stone, we set the stone, and then there's holes, dowels in the segment that's already built that'll accept the dowels from the new piece. We actually slide our ruler across the stones to make sure that they're flush with one another, and then place it from there. The erector will hold it in place while the cylinders come out and push it into place. And then once we get 2 pieces in, we'll start bolting. And then there's bolts that go in all the pieces to, keep it together.
Now comes the most challenging part of the build cycle. Between the inside diameter of the tunnel and the outside diameter of the ring, there's a gap and unlike soil, shale doesn't move in to fill it. On top of that, voids in the uneven rock surface have to be filled if the tunnel is to have structural integrity. The answer is grout, of course.
We worked for about a year to get the mixture correct. We started with something we thought would work, and then we kept testing it and testing it. The grout needs to cure within a short amount of time to be able to support the segments and keep them in place. Within the first 15 to 20, 30 seconds, we need it to quit acting like a liquid. We need it to become a gel. In 8 hours, we need it to have 40 to 45 PSI, pounds per square inch, of compressive strength. And then at 28 days, we need 500 PSI of compressive strength. The advance of the TBM depends on the stability of the rings, in that the rings can't squat. We can't afford to have any movement of the rings, otherwise the segments that make up the ring will start to break. From the surface plant to the holding tanks on the tunnel boring machine, we will have approximately 3.5 miles of 2.5-inch diameter steel pipe.
Mixing and injection of the grout and accelerator from 4 discharge points in the tail shield are visually tracked and meticulously monitored and controlled as to rate, pressure, and volume, taking into account all the imperfections produced by the mining cycle, machine wear, and the state of the delivery lines to ensure the right grout take.
It matters significantly to get the right amount of grout in behind the lining. If you put too little in, it creates voids, and these voids are a problem in the long-term condition of the tunnel. The grout on this project was a significant risk, and one of the reasons we identified it as a high-risk item to manage was the fact that it is a real possibility that you could stick the machine and never be able to move it again.
The hard-working people creating the Euclid Creek Tunnel have expertly repeated the cycle of mining and building, inspection and testing, troubleshooting and maintenance more than 3,500 times between the day the service shaft was ready and the tunnel boring machine constructed and in service on August 10, 2011. Until the August 2013 breakthrough to the terminus shaft.
When we hole through, it's the light at the end of the tunnel. You've come through, you've broken rock with steel for 3 miles. It's pretty satisfying.
The day we hole through, as we call it, that's like winning the Super Bowl or something. While you're mining, there's always a concern, what's around the corner? Are we going to hit bad rock? From once you hold through, you can breathe a sigh of relief, you're done.
That's the outcome of a sophisticated underground factory, continuously building itself while in production 3 shifts per day.
On any given day, we could have anything from 80 to 100 trucks coming in and out of our site. I have to be in charge of getting rid of all the shale that comes out of the tunnel. It's a 27-foot diameter tunnel, so that's a lot of muck coming out. Then we got the concrete segments coming in, and that's got to be scheduled, unloaded by the crane. We have a safety meeting every Monday morning, and we discuss what we're going to be doing that week. The number one concern is the safety of everybody. If one person gets hurt bad, that defeats the whole purpose.
Our relationship with McNally Kiewit has been a good relationship. We have very open communications on the project. We talk every day. We work through our issues before they become problems. And has really led to the success of the project.
When it's done, the Euclid Creek Tunnel will store up to 62 million gallons of wastewater. Wastewater diverted from 9 existing sewers during rain events and kept out of the environment until it's transferred to Cleveland's Easterly Treatment Plant.
In many ways, I think you could call our region a bit of an overachiever when it comes to water quality. The federal standard for combined sewer overflow control is 85% capture, and many cities across the country are only being asked to go that far. But because Lake Erie is in our area, we are going to be going to 98% capture, which is well above the national average. 25 years from now, when Project Clean Lake is completed, some of the benefits that the region will see are decreased bacteria concentrations on our beaches. We have a number of primary contact recreational beaches in Cleveland, as well as the lower part of the Cuyahoga, which is very active with a rowing club and boaters. So those areas will have less bacteria in them as a result of Project Clean Lake. We are very excited about our partnerships with the communities and hopefully leaving behind some amenities and as a symbol of the Project Clean Lake that they have invested in the region, in addition to the water quality benefits that'll be realized on the beaches and in the Cuyahoga River.
Water. Simple, natural, essential. In the 21st century, it's second nature to protect and secure for the future, a pure resource we can take for granted every day.